So looking at the media server process, media player service has a number of different things that it does. It includes the media player itself, media recorder service, and the camera service. And then underneath the media player service, what we've done, I think I mentioned earlier, we talked about expansion for the future. So the media player can actually instantiate a number of different actual types of media players depending on what kind of media you want to play. If you look in the center, we have a Vorbis player. Most of the native audio files that we use are OGG Vorbis files. And Vorbis is a perceptual codec that is reasonably efficient, and because it's also open source, it's very conducive to our application. So if the media player service sees that the file that you're trying to play is a Vorbis file, it will instantiate a Vorbis player. If it's a mini file, then it's actually a mini file player. And then if it's not one of those two, it goes to OpenCore, and OpenCore is responsible for handling all of the other types of codecs like MP3, MPEG-4, et cetera, et cetera. So once we've instantiated that, what we're actually doing is passing back a handle to the application process that it can now use to talk directly to that player. So we instantiate, let's say, an OpenCore player. The binder interface that we get back on the application side is basically going through a DEN proxy to the OpenCore player. And for each one of those players, an implementation of this abstract interface called media player interface, and defined in the media player interface.h file. So you can create a new type of player. So for example, if you wanted to have a Fiora player, or you wanted to have a GStreamer player, you could create a new media player. You just create a concrete implementation of the media player interface for that player, and it will now be able to play files. There's a little bit of work you have to do in the top level media player service to tell it how to determine which of the players to instantiate. So there's a little bit of logic in there that looks at the file extension or snoops a few bytes in the beginning of the header of the file to determine what player it should instantiate. In other cases, it may be looking at the URL, for example. So that's an easy way to extend it and add some new functionality. And we know the people that have added, for example, we know that people have done GStreamer ports and are using that in place of OpenCore or in addition to OpenCore. And so it's pretty simple to do that. For the media recorder service, it's also built on top of OpenCore, and this is where you can do audio and video recording. In the case of media recorder, you have the option in the application to either instantiate a camera directly if you're going to do a video record, or you can allow the media recorder service to create one for you. And then once that's done, you actually have a direct path from the media recorder to the camera, and I'll show you that later in another diagram. Of course, the other part of the media player or media server process is the camera service. So again, this is another case where we have scarce hardware resources that we're trying to allocate to different applications. And so the media service is actually providing a way of managing those resources, so only one application can access the camera at a time. If the camera's busy, another application tries to access it, it won't be able to create a camera object. So looking at the way a media playback session works, the application is going to create a media player through the media server. And there's a few simple things that it is going to pass across to the media server process. It passes a data source. This could be a URL, it could be a file, it could be an open file descriptor. We'll talk about that a little bit later with the security model. It passes an iSurface, which is the binder interface for the Surface Flinger surface to render the video. And then it also passes the type of audio that you want to output. And this has to do with how audio gets routed into Audio Flinger. So once you've done that, the iSurface is used to send the composited video to the Surface Flinger. and the audio type is used to route audio within the audio flinger. So after the session is started, the application really doesn't have to do anything else. It does you do a set data source to tell it where to get the data from. You do prepare to tell it to allocate the resources. If there's hardware codecs involved, it will instantiate a hardware codec or a software codec. And then the next thing is to do call start, and at that point, the application is no longer involved in the process. The media server will actually do the decode, do the AV sync, it will hand off the finished frames to the audio and video circuit swinger and audio flinger. So it's very lightweight, and that actually makes it nice because we're going across this process boundary. We don't want to be moving a lot of data across there. And then looking at the media recorder, it's a little bit more complicated because of the camera service. So in this case, the application can create a camera. And the reason you might want to do that, for example, is if you have an application that takes both stills and video, you can create a camera object. You can have, say, one button that snaps a still image, or another button that starts a video record, and it makes it really easy for the user to switch between one or the other. So in the case of when you're passing the camera object, you actually temporarily unlock the camera, give it to the media server, and the media server does its thing with the video record process. And when it's done, it will unlock it and hand it back to the application. Again, you're passing an iSurface. In this case, instead of rendering the playback video, this is used to render the preview display for if you're doing a video record, or if you're snapping a picture and you just want to see the preview in the video. And again, there's an audio source. In this case, the audio source is for the input. Typically, that's going to be the microphone. Once you've done that, you do, it's very similar to what you do with the media player. You're going to do a prepare, start record, and then stop record. And once you've done start, the application is no longer involved in the process. The media server handles all the frames, pulling the frames from the camera, feeding them to the encoders, putting timestamps on them, making sure the audio and video is synchronized, and then outputs that to a file. So now we'll talk briefly about the security model for the media server. One of the things we've done is we've isolated all the parsers and the codecs into a separate process. So your MP3 codecs, your MP3 file parser, et cetera, all of these things are located in the media server process. Now, the reason for that is it's really hard to write a codec, for example, that's very efficient and also not subject to some sort of security exploit. But doing all the bounds checking you need to do to make sure the stream is valid is tricky to get right. You almost never get it perfect the first time, and it induces an additional overhead when you're trying to do those bounds checks. So rather than kind of do the impossible and come out with a perfect codec, we decided the best thing to do was to take this approach we call sandboxing. So sandboxing is basically putting things that are vulnerable into a separate process and assume they're going to be compromised by some sort of security hack. And then the trick is to make sure that it's running at a privilege with minimum privileges that it needs to do what it needs to do, so that if it does get compromised, it's not going to compromise the user's data. And so doing this, we've been able to, we had an actually exploit shortly after 1.0 where a security consultant had figured out how to fuzz the MP3 player and basically break the codec. And because of that, there was no way to compromise the user's data because the user's data is not in the media server process.